the material cost, the labor, and the overhead really, they basically take up the most money. But in essence, they have a very little influence over our ability to influence the market as far as drivability, let's say, for automotive, or profitability for the corporation itself. So if you look at it, you can see that the 5% investment, which is engineering over the life of the project, really and truly has the most influence. So we're focused on engineering and product design. And the way we do that is by using a little philosophy that we have. And that is, the Monroe philosophy is seeing what everyone else has seen. Men looked at birds forever, but in essence, they had to think differently in order to come up with an airplane. There are no feathers on the airplane. It doesn't flap its wings. So what we want to do is look at everything everything that has been put in front of us, but think about what we can do differently in order to make a product far superior to what it is now. Our product today, the thing we're going to focus on is the BMW i3. There are many articles out there. You can go to our website. I think there's some sort of a download that will send you to all the articles that are out there, which have a lot of information in them. Normally, we don't give out any information because the information is owned by whoever the customer is. But in this case, we did it on our own, so we can talk about this freely. And I will tell you, without a question of a doubt, the reason I did this was because I thought this car was revolutionary, but I had no idea until we got into it how dramatically different this is from any other vehicle we've ever taken apart. This is, without a question of a doubt, the watershed for a new product in the marketplace. I believe this has as much impact as the Model T did in its day. So, next one. So, what does the product look like now? Well, right now it's in bits and pieces, and as Mark will tell you, we go down to the nth detail. We're into counting the number of balls in the ball bearing races. Actually, we go further than that. We actually cost out each one of the balls in the ball bearing races. We want to know what the materials were, what the processes were that were used in order to manufacture it. This has more detail than anything, certainly anything that we've ever done for any of our customers, and I can guarantee you that our detail is greater than what our customers have. So this is about as detailed as it could possibly be. There's nothing that escaped scrutiny. There was no such thing as we'll just call this a commodity and give it a lump price. We went right down to nothing on everything. So what I'm going to do is, our next slide up is the BMW i3, and what I'm going to do is pass this over to Mark, and he's going to tell you about the processes and exactly how we scoped out the i3. Mark?
Good morning, afternoon, or evening, whatever the case may be. As some of you may know, we started this adventure as a costing analysis of the BMW i3, and what we ran into were technologies that were so interesting and so radically different from other things we have done that we wanted to share some of our insights with you. In doing our analysis, we use our Design Profit software, and it's a processing adding machine. It is a keeper of all of the information that we find out during our teardown. It's a software program that uses a symbology to show parts, subassemblies, pre-processed parts, tools, fastening operations, material modifications, inspections, parallel processing in the manufacturing world. It gives us the ability to put within symbols all of the information of each individual part, be it a fastener or a material. We can put in all of the properties, the weight, plus we can put a photo of each of the components within assembly on a car. So basically what we do is we build a virtual factory that we start with a subassembly, break it down into its various components. As we dive deeper, we look at each of the individual processes needed to make that. Say if this were stamping, we would have a stamping operation, a deburring, trim operation, a wash operation before that part is ready. And what the software does is it additively calculates up all of the times required to manufacture these parts, and through the use of a cost center, which is basically the machinery, the labor, and the floor space, the utilities required to do specific operations are all added up so we can come to a total cost for what that product would cost to manufacture. And the nice thing about it is it also gives us a visual of each of the operations needed to manufacture that part. Over on this side we show assembly operations, to where if this were in a vehicle, this would be the subassembly, this would be the cost of the components, and this would be the operations and cost of the assembly operations to put it in a vehicle.
Well, before we skip off that one, maybe one thing that you all should know is that we actually developed the cost centers for each center is developed in the country or the area of origin. So we found out that some of the components that are manufactured for the BMW i3 are actually in places like Morocco. That's not what we would have classified as a hotbed for manufacturing, but we developed cost centers specifically for Morocco. So Moroccan labor rates, Moroccan taxes and utilities costs, and everything else that's associated with one of our cost centers had to be developed for each individual area. So what you're looking at is the true cost to BMW on each individual component.
We also have internal worksheets that we use to calculate times of various manufacturing processes. This being an example of a die casting where we take specific measurements, wall thicknesses, percent of loss of, from the original casting for machining to come up with the inputs that go into our design profit map. And we have this for not only die casting, but stamping, injection molding, all of the various manufacturing processes that require different sizes of machines for different parts. We have calculators developed to give us costs and time and material costs for specific individual components. One of the other things that we do when we tear down a component and do an analysis of it, these two pictures, here's the full battery pack from the BMW i3, and here's one of the modules that are inside of this battery pack. When we do a tear down, we start with a specific subassembly, and in this case I've got a photo here of the insides of the battery with the can removed. And the way we do our analysis is we start with a subassembly and break it down into its next major level of components. And at this point we have 102 parts for this cell stack assembly. At the next level we'll break it down and we will take the cover and the current collectors off, and what we have are the windings that were inside of the battery. And you notice we have a total part count of 70. So the deeper we dive, the fewer components there are. Now this is one of those individual cells that were in the previous photograph, and it has a total part count of 18 parts. And as we take it apart further, if this will click, we have basically the cathode of the winding, which is a substrate and all of the chemical components that make up the substrate for the battery, and then we have the anode, which is the substrate and its individual chemical components. So that's how we dive down into a product. If this were a gearbox or a motor, we would start with the main motor as the major assembly, and then we would break it down component by component by component to get a total cost and a map of how these parts were manufactured. And that brings us to some of the interesting technologies. We had over 20,000 slides that we've developed for this project so far to kind of break this down into a half-hour discussion of some of the neater technologies that we found in this vehicle. And what we call the body in black is the carbon fiber life drive module that is used in this car. The outer shell of this is comprised of 9 preformed parts that are placed individually into a mold and molded into one structure for the body. So when they do the resin transfer in the mold, this becomes one part that gets placed onto a assembly, creating the life module. And some of the other technologies that we found is that the roof panel is made out of the scraps from the preforms that make the body. They're chopped up, realigned, and used again. And there are also other plastic structures on here, crush cans, that are all a part of the design used to make the life module.
Before we dance off of that one thing that I found to be extremely interesting about the life module is that on the floor pan or in the floor area holding the seats down are some rather large aluminum stampings. We do a lot of work with aircraft as well, and one of the things that oh, I'm sorry, I didn't know that was in there. Sorry. Okay, we'll get to it. Never mind.
Okay, we'll go back here. So anyways, the carbon fiber waste is recycled and integrated into the vehicle roof, and the thing that is very apparent in looking at the design of this vehicle is that they've taken into consideration all of the upcoming EU recycled requirements that they have for vehicles, and this looks to be a test bed as to how to do that, how to reuse materials, and how to be able to recycle an entire vehicle. And we'll discuss that a little more as we go on. And this next slide shows that, and we were quite impressed that this life module is put together as a single component and placed on the frame on 2 pins. So basically the adhesive that holds the life module to the aluminum frame, the adhesives are placed down, and this entire frame is located by 2 pins, and the body are married together, and it's a very elegant way to align 2 different components that are so important in the design of the vehicle. So, and we've identified some of the epoxies that are used in making the carbon fiber materials, and we have cure times based on published information that basically we look at the resins used to make the carbon fiber materials and the epoxies bonding these materials together, and this information is all available, I believe, also on our website. As mentioned before, the roof of the life module is made of scraps of carbon fiber trim from other components, re-put together, and it actually ends up being a Class A high gloss surface, and the door surroundings are Class B exposed technology, so they are showing off the carbon fiber within the vehicle itself. And as Sandy was mentioning, the life module is comprised of 90% carbon fiber and 10% other materials. And one of the more interesting things was the aluminum floor pan. Today, when you talk to most auto companies, they're trying to figure out how to make a plastic or a carbon fiber floor pan, and what BMW's done is made the rest of the body carbon fiber and put an aluminum floor pan in, which is used for mounting the seats. And the interesting thing was how they did the overlapping, sandwiching the carbon fiber reinforced plastic panels to hold this aluminum floor pan in position. And if you can look at these photos, you can see where the aluminum floor pan is sandwiched in and adhered to with adhesive the carbon fiber. And there's a couple of other examples where the carbon fiber comes up in between two aluminum sheets to hold this floor pan in place. And one of the advantages of the way they've done this is they use the adhesive as a barrier to eliminate any galvanic reactions between the different materials, because if the carbon fiber and the aluminum were to interact with each other, there would be a possibility for galvanic corrosion to occur. But because of the use of the adhesive, they keep that from ever marrying together and creating a corrosion issue.
Well, yeah, the other issue there is that in the aircraft world, we probably wouldn't do something like this because the thermal expansion of the aluminum is quite a bit, whereas carbon fiber is more like a stone. It doesn't expand much at all. So having those two materials that are so dissimilar when it comes to thermal expansion was a very big surprise to me. We can't do this successfully in aircraft, so I was very, very surprised to see that this is located in here. Now, in an airplane, you're looking at probably minus 60, 65 C as a normal cold, and then you'll see the same sort of 150 C kind of numbers that we would see in automotive on the ground. But I am surprised that they could make this work. We haven't quite figured out how they do all of what they do here on the BMW, but this to me is one of the most groundbreaking, because no one I know of has been able to make this work. I'm very, very impressed with their use of dissimilar materials on this car.
One of the other interesting features of this vehicle is the frame itself. Over here, on this side, we have a bird's eye view of what the frame looks like with everything removed from it other than the extruded aluminum shell, and then there are die castings that are welded to support the suspension components. And big square in the middle is where the battery pack would be mounted, and that also adds as a stiffening structure to this aluminum composite frame. So if we were going traditionally, we would never look at welding a die casting to an aluminum extrusion. Now, this has been done before in certain instances, such as the Audi A8 frame and the A2 body, but they were using die castings as connecting components more than as structural features within the aluminum welded assembly. But this welded assembly has an extruded frame, a die cast component. They're MIG welded together, and it is a structural weld that is holding this thing in place at one of the most critical stress points on the vehicle. And so we were very surprised that this had occurred, and with the welds I have taken apart so far, we know that these are very low gas, high density die castings, because there's no signs of any kind of gaseous bubbles within the welds. There's no sign of any kind of hydrogen embrittlement on the castings. It's really a advancement in the technology of being able to weld the die casting to an aluminum extrusion. One little test I did do, I noticed that the hardness of both the extrusion and the die casting are very, very close to each other, and so I'm sure there was a lot of engineering effort put into marrying these two components together and being able to so easily and so successfully weld them together. Do you have any comments?
No, except that this is another one of these features that, that prior to tearing down the BMW, if someone had come along and said that we were going to see a frame that used this kinds of technologies and materials, I would have just either started laughing or walked away. We've all been very, very impressed by what BMW has done in this area. And now knowing what we know about how it was done, anyone that wants to take a chance on this kind of a product or process, they would benefit by finding out how this was done, because the BMW people we know spent, I think I was told by BMW, $3.2 billion in R&D in order to get this product to where it is right now. So this would chop a lot of cost out of R&D, knowing, you know, how this was done.
One of the other interesting elements we found on the car was with the closure. We did a thorough fit and finish assessment of this vehicle when we first got it. We basically measured every gap, every opening to see how well this car was put together. And based on people who have done these kind of assessments before, they said that this was probably hands down the best fit and finish check they've ever made on a vehicle. And so, being that the outer panels were all plastic injection molded panels, we were wondering how they could get this alignment so close. And it was until we took the panels off we noticed that the inside of all of the doors are aluminum extrusions, stampings, weldments welded together, and they have these adjusting snap fittings that the door panels go onto that will allow for the adjustment and the ease of replacement of any of the door panels in the Y direction. So as long as the hinging system stays in line, they have an adjustment available to keep the fit and finish of this vehicle hands above everyone else we've looked at so far.
By the way, yeah, we might want to put in the scale. We've torn apart probably about 450 vehicles. Of those, about 150 have been analyzed, not as detailed as this one, but fairly detailed. And of those 150, none of them came in with scores as low as what we saw here with the BMW i3.
Very good. And another interesting thing we were just discussing with some of my associates who've worked on this. This door frame is a welded structure with 24 components. The rear door has 7 stampings and 17 extrusions plus fastener inserts. And we're thinking that in doing all of this, being a low volume vehicle, we think this is probably just a way to do a low volume vehicle without large capital investment. And our feeling is that in future vehicles, this would probably, when they get into higher production vehicles, this would probably be changed into a die casting or a combination die casting extruded system that would be used rather than all of these individual components. But we just thought it was a very nice way to develop an elegant system without high internal investment costs, and a way to, you know, they seem to be working very, very hard and improving their ability to weld aluminum to aluminum structures within the vehicle.
The other thing that sometimes we forget about when we do things the same way all the time, most people will just immediately run to a unibody construction, but if you have something under 50,000 vehicles a year, that's probably not your best option, simply because the investment is so high that cost has to be passed along, and it never really makes a whole lot of sense when you're looking at lower volumes. This car, I think, we haven't totaled up everything yet, but I think this car is going to be one of the lowest investment costs. You know, removing the fact that they put up their own factories and whatnot, they did that for other business reasons. But if we just look at the vehicle itself, I think it's going to be one of the lowest cost, as far as investment is concerned, vehicles that we've seen for a 3 Series size. Certainly, if you compare this to the BMW 328i or something like that, this thing comes in at chump change in comparison. So these guys were not only good at the engineering, but also extremely cognizant of the fact that we had to make dollars and cents on this. We usually draw a comparison between this vehicle and the Chevy Volt, which for those of you who follow the press, I made some comments about how much that cost, or how much the vehicle should probably cost based on the $18,000 that they were putting out per year. This vehicle actually, I think, can make money because the investment cost is so low.
Okay, we're getting near the end of the presentation, and so I did want to bring in one of the other subjects of high interest that we found, and that is the battery pack. The battery pack for the i3 is 365 volt pack. It contains 8 modules with 12 cells each inside the pack, and it's bolted to the bottom of the frame, as I showed in the previous slide where the opening was in the frame, bolted right to the bottom of the car, and it is very well engineered when you get inside. This battery pack is probably one of the best I've seen in 30 years of working in the battery industry, and it's interesting how they have used distributive control systems to monitor and charge the 845 volt modules. Each module within the battery pack has its own controls, which means that it can be replaced if there's a battery failure. They can replace just one module and the rest of the battery pack can stay intact. It requires very limited work in order to remove a battery module. This photo here shows that in order to replace the module, I have to disconnect the major bus system for the main power. I have to disconnect the CAN bus from the control module. I have to remove any supporting plates that are in there. In this case, it would be 2 plates with 8 bolts. Once I've removed those things, I can take the 4 bolts holding the module in place, pull that module out, replace a new one, plug these components back in, and my battery pack is ready to operate again. In most other instances where I've taken apart battery packs, if a cell goes bad, typically you scrap the entire battery pack and start over with a new one. This was very well designed in order to avoid that, having to scrap the entire battery pack when you have just one cell go bad.
Well, actually, the one other thing that we noticed about this was these things are reusable, and you could probably, even though it's not good enough for your car, you could probably pick one of these things up, put it in your basement, and if you accrue enough of them, you could use that as backup power for your house. So a lot of cool things associated with the strategy behind the battery system.
Yeah, so as I was mentioning, in the case of you having to remove the battery from the vehicle, basically you unbolt the battery pack from the bottom of the vehicle, drop it down, and in order to do that you have to remove one electrical connector, being the main power connector, two coolant lines for the coolant system, and the CAN bus line, and you can drop this pack from the vehicle. Very well thought out design. And so I think at this point I would like to turn this back over to Martin, and we would be happy to entertain any questions that you would have.
Well, thank you, and thank you for entertaining us so far. It's been a fascinating insight into the vehicle. I think also for those of us who don't know too much about teardowns, it's been interesting education in how this process works. Perhaps if I can just put a question to you before we go to the floor. I was keen to know literally how you do a vehicle teardown, because all of the parts that you've shown are not broken. They're intact parts. This has been done very painstakingly carefully, and I'd just be keen, before we go into the specific questions that people have sent in, to understand how you do this.
Well, I tell you, I've always been a little suspicious of structural adhesives until we tried to tear the body, the carbon fiber body, off of the aluminum frame. If you would have been here, you may not have made that comment. It took an extreme effort of days and days to basically vibrationally cut through that epoxy to get that body part off. But yes, we do try to take care, because we do have to weigh, photograph,
exactly. If you're trying to weigh something,
measure every component of this vehicle. So we've developed some methods that are very good for taking vehicles apart, and sometimes we have to use a sledgehammer and
I was going to use that as a joke. I didn't realize.
No. Sometimes we actually have to, physically force things apart in order to do that. But when it came to the adhesives that are holding this carbon fiber body to the aluminum frame, I was amazed at how strong those joints were. Actually, I trust the adhesives now more than I do spot welds. Any instance.
Yeah, I concur. I think we developed a whole bunch of new disassembly techniques, because yes, the body was the body from the frame was a nightmare. It took us over a week to get that thing to pieces, and we found some trick ways. There's people that take out windshields and whatnot. They were trying to help us, and most of the conventional stuff that you'd find really didn't work out well. But we did discover some of those secrets, which we're going to keep to ourselves. But the long and short of it is that when we do a product, at the end of the day, people look at it and think that maybe we got it from a supplier or something. So we do our absolute best to make sure that everything is as intact as it can possibly be. So if a customer needs to look at it or wants to get more detailed information about it, it may not be a virgin anymore, but it's not destroyed. So.
Okay, well, one of the questions that's come in might be a nice follow-up to what you said about how well the vehicle was put together. Somebody's asked, did your investigation help to identify potential areas for improvement in the overall manufacturing process with a view to enable higher volume carbon fiber deployment?
We know that is interesting, but the level of automation that BMW has used to put this vehicle together is rather astounding. I think I think the only areas where they could improve their throughput would be there are several parts of the carbon fiber manufacture process that are still manually done, like with the large components for the side frames. From the videos we've seen and from a plant visit to their plant, these are still manually placed into the molds. I'm sure at some point they will be able to automate some of that process, but the use of robots, the use of technologies for cleaning where the adhesives get applied are above and beyond, I think, a lot of plants that I've seen. They've done a really, really good job at integrating new technologies into assembly areas.
Yeah, there's a couple of things. We brought two more folks in, but the question actually has two edges. One is the factory floor, obviously, which Mark was addressing. But then we have, as we look through it, there are a couple of things that could have been redesigned, re-engineered, to make them a lot less costly, and in some cases even reduce the weight a bit. One of them I just looked at yesterday was a hinge that's actually forged steel. Probably I wouldn't have picked that from a weight reduction standpoint. And then I also looked at the cover that goes over the top of the battery, which has, I don't know, a gazillion screws. 36 screws. So we could have probably done something entirely different there that would have kept the same amount of stiffness, but gotten rid of quite a bit of labor and definitely the weight of the screws. So the design could be improved. There's no question about that. And also there are opportunities on the factory floor to increase productivity. But I know Todd, I have Todd and Steve. They're the two guys that worked on or are working on the life module, the carbon fiber module. So Todd, you had something?
I think one of the areas where we'll see increase in production speed is with the advances in chemistry producing ever faster cure times.
Yeah.
So we're already incredibly fast at a 6-minute window with the aerolite system that BMW is using. However, some of the other resin manufacturers are getting close to the 1-minute cure time. So that's an area where the process will speed itself.
One of the biggest problems, though, is that it's not so much the cure time that's an issue, it's the time that it takes to put everything together, and the ablation process that they use for laser ablation that they use for getting ready to modify the product so that it can be like the lay down body side rings can go to the rest of the body and whatnot. These kinds of things actually are going to be some of the limiting factor as well. I'm pretty sure that the adhesives can go wicked fast, but we're still going to have the handling issues and whatnot, because as it moves from one place to another, it's not really in the initial forming stages and whatnot. It's not what you'd call robust. So we'll probably see some advances in the cure times, but I think that the real focus might be on how do we handle this thing so it doesn't bend or break or move while we're going from the presses into the RTM machines. Yeah. Did you
interesting because, sorry, go ahead.
No,
go ahead.
Go ahead. Yeah.
I was going to say that it's interesting that the two elements of this vehicle that make it so special are the fact that it is all electric, but also the fact that it is so carbon fiber intensive. On the point you made about how, despite everything that you've seen on this vehicle, you believe, or because of everything you've seen on this vehicle, you believe that this vehicle can still make BMW a lot of money. one of the questions that's come in is that the carbon fiber used for the BMW i3 just to reduce 1 pound costs $10 to $12, which is not sustainable. Given the fact that it is an electric vehicle, it is a carbon fiber intensive vehicle, and you still think it can make money, does it matter that the carbon fiber itself is, let's say, not sustainable in terms of cost?
Well, here's the problem. People are looking at pounds to or kilos to kilos, right? So I have a kilo of steel and I have a kilo of carbon fiber. And what people are forgetting is that it's not just that relationship. You're also looking at volume reductions, and volume is worth money as well. So when people come along and say, "Oh, we want to buy that because it's like $25 a pound or something like that, or $18 a pound," that kind of stuff, it doesn't mean anything. There's no comparison. What we have to look at is the stiffness module, because this thing is as stiff as a brick. There is nothing that we've seen so far that has a modulus like this thing, and it's perfect build every time. There's no there's no variation. There's no spring back. I've worked in a lot of different factories, and spring back from aluminum or steel, the welding processes and whatnot, trying to muscle the body in white back into position using 2x4s to like bend the doors so they fit. That stuff's all gone away. That's got to be worth some money too. So when people start saying, get fixated on one thing, like the cost of the materials, and that's basically what we've done here, is we're looking at a total accounted cost, not just one individual cost in isolation. You can't really look at this in isolation and see a business case. You have to look at total accounted cost. So that's kind of what we're trying to do, and it has nothing to do with what the price of the material is. It's the added effects, the total accounted effects that you're going to get out of using this kind of a process. So.
And an interesting aside to that is in one of the videos that BMW put out themselves, they said that the total investment BMW made in the plant for the carbon fiber life module was about, and this is quoting their video, about a third of what it would cost for an investment for a traditional body in white facility. So there are other advantages that can be had while using these materials that will affect overall cost.
Right. It's important that everyone stops thinking metal to metal to metal. Well, high strength steel is going to cost me this, or 1020L is going to cost me that, or whatever. That's not the way to look at it. What's the total accounted cost? What ramification? Because let's face it, the body in white in the frame is the fixture, and that fixture determines everything else from a quality standpoint, from a cost standpoint, from a rework standpoint. Everything is all dependent on body in white, regardless of whether it's made out of steel or it's made out of aluminum or it's made out of whatever. And one of the things as a process engineer and somebody who's worked on car programs forever, one of the things that I come up with, and when I'm looking at this, is what did I just avoid by doing what I'm doing here with this BMW? Okay, all my components are in a perfect position. My body is a perfect build. Most guys that work in a body shop, a body and white shop, or stamping line, their ultimate goal is to get 5 good holes. This product has more than 5 good holes. They're all perfect. Everything is in the right spot every time. That's worth a lot of money, believe me, and a lot of grief goes away when the product is a perfect build.
Okay.
Back to you.
I'm conscious of time. We still do have time, but we also have many, many questions. So I'm going to throw a few at you. If I can just ask you to give some brief answers. Let's stick with the body of the vehicle for now. We'll move on to the battery in a moment. I've had various questions about the roof. Is it a structural part? Could it be used, or rather replaced with some form of panoramic roof? And I'd like to know as well whether there's an opportunity to add in some form of solar panel into the roof.
Well, you know, I'm sure there could be a way to put solar panel into the roofing structure, because that's a relatively simple thing to do. I think from a structural standpoint, there are, what, 3 cross braces? There are 3 cross braces in the roof structure, and one of the nice things about using the carbon fiber for the cross braces is that the way they lay the unidirectional carbon fiber layers is that they can provide strength in a direction where they need it. And so I'm thinking that the can we put a sunroof in it? Maybe, but I think it would not lend anything to the real beauty of this vehicle and the way it's designed.
Yeah, I think the solar panel idea is that's a piece of cake. The other one we'd have to think about that. Yeah.
It's tough.
Okay, you talked about the fit of the vehicle. Let's move on to the finish of the vehicle. Somebody would like to know, how does the quality of the exterior panels compare to what you've seen in aluminium and steel in other vehicles?
It's better.
They have gone to great lengths to perfect the painting of plastic.
Yeah.
They use plasma treatments on the plastic to provide a proper surface oxidation so you get good flow of the paint as it's sprayed on. They have several painting steps that they go through. They also have this really nifty, I don't know if it's carbon dioxide or nitrogen ice crystals that they use to dust off the panels prior to painting. It's done with the ultimate of care, and as far as I could tell, every outer panel is hand sanded and repainted prior to being installed onto the car. So the finish is absolutely gorgeous.
Excellent. Okay. Well, as I said, we've got many questions on the battery pack as well, so let's just take a few of those. I guess the most important question, I think this is no secret, but I can't remember off the top of my head, who makes the battery pack?
The battery pack is assembled within BMW.
Right.
The batteries that are used within the battery pack are Samsung SDI.
Right. Okay. And do you think there's an opportunity in the vehicle for battery switch?
Oh, absolutely. Absolutely. This is one of the best, like I said, this is one of the best designed battery packs I've ever seen. And it does allow for battery switch, but it also allows for replacement of a portion of the battery pack without having to go through the investment of the entire battery pack being replaced.
Right, okay. Could BMW use a higher density battery to improve vehicle range?
As far as density, I'm not sure what they're getting at. That's everybody's issue for the last 15 years.
Even longer than that. We worked on EV.
Yeah, and trying to improve the performance of the battery. They're using a 60 amp hour cell. They've got 96 of these cells in the battery pack. The way they have designed the battery pack, it looks like it's going to have some of the best longevity from the standpoint of how it is assembled and how the cells are connected together. If there was a different, denser type of battery that they could use, I really can't off the top of my head know where that would come from today.
Unless they decided to decrease the amount of battery that has to not be touched. I mean, they only use like 20% or something like that. So,
if someone came up with a deep cycle battery, they could immediately improve the range of the vehicle. But that's what all the battery guys are working on right now, is making those improvements.
Right. Okay. We hear a lot about how much wiring weighs in a standard vehicle, up to 80, 90, 100 kilos. BMW is a member of the Open SIG, which looks at 100 meg Ethernet to transfer data around the vehicle and so on. Did you find any evidence of attempts to lightweight the wiring harnesses in the vehicle when you were doing your teardown?
Absolutely. Within the battery pack itself, instead of running instead of running 12 wires, 96, let's see, instead of running 150 wires from front to back in this battery pack, they ran 6.
Right.
And they kept local all of the battery connections and basically ran a bus to a motherboard within the battery pack and ran a bus from the battery pack to the main vehicle controller. So yes, there were evidence of that all throughout the vehicle and especially in the battery pack.
Okay. And from the battery to the
even the electronics modules, we didn't have a chance to talk about that, but we also analyzed every electronics module right down to the last resistor. And even the electronics modules were they're as good as what you could find in a computer. They don't look automotive at all. Everything in the electronics modules has also been analyzed, scrutinized, and cost reduced, and whatever. It's that's a whole different topic all by itself. So.
And you can tell that there was distributed control within this vehicle because there were upwards of 70, 72 different printed circuit boards within the vehicle.
Yeah. The other thing is they even did lightweighting on things we're not talking about it, but they even did lightweighting on the motor itself, the electric motor. We don't exactly know what all of these different, they've got a bunch of different slots in here, different than we've ever seen before. We don't know if it was reduction of weight or whether they've got some new electrical impedance thing.
Yeah, we didn't have time to get all the slides, and you will get slides of the motor in the packet. And one of the things is they developed this motor at BMW themselves, and it's a very high reluctance motor, which gave them the ability to lightweight the rotor to a level that I've never seen in any electric drive motor for a vehicle. And so basically they were able to take out a lot of the material weight from the stator. So in lots of areas. Interesting.
Okay, just a follow-on from looking at parts beyond what you've discussed today. We've had various questions, people asking if you can tell us anything about any secrets in the electric motor and the regenerative braking system.
Mostly it's in the design of the motor. The regenerative braking system is very similar to what you would see on any hybrid electric vehicle, but the motor itself was designed to provide much more power with much less material within the motor itself than your standard traction motor that's used in an electric vehicle. So they've done a good job of redesigning almost every part of the electric drive system and optimized them weight-wise and power-wise.
Actually, there's another thing too. We bought the RX version of this vehicle, so it's the extended range. And that extended range option has a small generator. The gas engine, it's a motorcycle engine, and it really was no big wow. But we were very impressed with the generator, which was also redesigned, again, with the focus on how do we get the maximum out of this little generator? Unfortunately, we didn't have time to talk about that either.
Interesting, actually. We haven't had any questions about the extended range version, and you don't hear much about that either. It's something that I understand BMW brought out because it felt it needed to, but that over time it expected to see the numbers dwindle. Is that an impression that you get as well?
Yeah, we think actually I got to the car last as far as driving it around before we disassembled it, and when that thing kicked in, it scared the crap right out of me because it's a very, very quiet vehicle until that thing kicks in, and then that really wakes you up. So I believe that it's a city car and it has enough range to do whatever you need to do in, say, London or something like that. But I don't really see people rushing out to get the RX version. I wouldn't do it if I was going to buy this vehicle.
You raised a really interesting point there, which is about NVH. Did you discover any secrets or anything that you weren't expecting to find regarding NVH when you were tearing the vehicle apart?
You know, with NVH, I think BMW does as good a job or a better job than 90% of the luxury vehicle market out there, and where needed, it was there. I don't know if there were any secrets about it, but within every area of the vehicle that required NVH insulation.
But there wasn't much.
There wasn't a lot because part of the nice thing about the carbon fiber body is that automatically eliminates a number of rattles and noise generators within the vehicle. So was there anything extraordinary? No, but was it there? Yes.
Yeah,
Definitely tell.
Yeah, but the big secret is the stiffness of the body. That's their real. For me, it was a giant eye catcher when we started looking at how stiff that thing was, and that just totally blew me away. That's why they don't need much in the way of NVH. And
okay,
it is quiet in there.
We have very nearly reached the top of the hour, but there's two other issues that have, or themes that have come through in the questions that people have sent in. So I'd just like to address these very quickly. One is to do with collision repair design in the vehicle, and the second is what other OEMs might be able to learn from BMW. If we can just tackle collision repair very, very quickly, did you spot any evidence of attempts to make it easy to repair a vehicle, let's say take a section of carbon fiber and replace it, or anything else that you might be able to share with us?
There are actual markings on the body that show the technicians where to cut in order to do repairs from various segments on there. So yes, that has been addressed. I think right now, I know within the United States, I think there's only a few locations, if not only one, where this can currently be done. But this has been documented and it has been thoroughly thought out by BMW in order to do that.
We actually have the repair procedure manual. I don't know how we got it, but we did. And I've gone through that. In fact, it's sitting on my desk right now. I've gone through that. And in essence, 99%, I think it is, or 90% of the vehicle, if it gets into a crash, can be handled easily. There's 9% that would require a technician or something like that, and less than 1%, actually a very, very small percentage of the crashes and whatnot might require some modifications to the carbon fiber. Looking at it, we have the crash tests as well, the Euro crash tests, and that car gets the maximum amount of stars in Europe. I haven't seen what the EPA has done here or NHTSA, but my guess is that it'll get the same sort of deal here. Even in narrow offset, this car handles phenomenally well from a crash standpoint. What was the other question? The
second part was, I just wondered if there's, well, you mentioned at the start that this is as important a vehicle as the Model T I wonder if there are any techniques or methods used in this vehicle that you expect to become industry standard at any time soon.
Pretty much everything. We wouldn't have done this if no, this is as good as it gets. I mean, the guys that don't get involved in this,
all over the place, so.
Well, they're going to be left way behind.
Left with the dust.
Yes, this is a what we call a paradigm shift. There's nothing here that if we don't implement it, if you don't implement what you see in this car, you will either gradually or rapidly find yourself out of business.
You know, and if people require much more detail on this vehicle and the things we've done, you know, we can be contacted in order to provide the reports that we've made. We are selling reports. We are putting this information out on the open market for anyone who wants to know in depth what's been done on the i3 vehicle.
Well, it's been absolutely fascinating, and we've scratched the surface of the questions that have come in, so I think you may be getting a few questions coming your way directly through your website. We will direct people to your website at the end of this webinar. I'd like to thank Sandy and Mark for giving us their time today, for the fascinating insight into this vehicle, and it just remains for me to thank everybody who's joined us for this webinar today. I hope you found it as useful as I found it interesting, and we look forward to seeing you at the next Megatrends webinar. Thank you very much.